In my last video, I discussed permaculture and how it fits into the greater context of humanity's journey on Earth. In this video, I will discuss what soil is, why soil health matters, and practices that foster healthy soil. To address what soil is, let's start with what soil is not. According to the U.S. Department of Agriculture, Natural Resource Conservation Service, soil is not an inert growing medium. That is to say, it's not just dead stuff we plant seeds into. It is much more. So what is soil? Soil is a living and life-giving natural resource. It is teeming with billions of bacteria, fungi, and other microbes that are the foundation of an elegant symbiotic ecosystem. Soil is also home to soil fauna, like earthworms, collembolans, mites, nematodes, and protozoa, all of which participate in the genesis of soil. What does this mean? This means they participate in the creation of soil. Essentially, soil consists of several communities of tiny creatures, from earthworms and nematodes to fungi, bacteria, and microbes. And these communities together create and manage the soil. So it should be a no-brainer that soil health necessitates no spraying of toxic chemicals which would hurt these little guys. Okay, so what is soil health? Soil health, as defined by the Natural Resource Conservation Service, is the continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. Healthy soil gives us clean air and water, bountiful crops and forests, productive grazing lands, diverse wildlife, and beautiful landscapes. Soil does all of this by performing 5 essential interrelated functions, which are regulating water, sustaining plant and animal life, filtering and buffering potential pollutants, cycling nutrients, and providing physical stability and support. First, let's hash out these 5 essential functions, and then we'll move on to the NRCS principles for managing soil health. So soil's first essential function is to regulate water. This means that compacting soil through repetitive tilling does not create healthy soil. It degrades the soil. This is because repetitive tilling creates a sort of concrete effect which increases the runoff during rainfall. Overturning the soil also exposes organic matter to the sun, killing off the soil life. Healthy soil is made of sand, clay, and humus. Humus being the organic matter formed by the decomposition of plants and animals, rich in nutrients and retaining moisture. Healthy soil is porous, allowing for ample water and airflow, and storage. The NRCS states a healthy soil profile has about 50% pore space for the movement of water, holding water like a sponge. It should look more like fluffy chocolate cake than concrete. What the idea of healthy soil regulating water also implies is that in appropriate circumstances, it will bring about the creation of earthworks like swales. Ken Yeoman, who initially developed keyline water management, a staple in permaculture and regenerative agriculture, described in his book, Water for Every Farm, that humans have become quite competent in forming buildings, but have much learning to do in forming the land. Land forming is a valuable tool to incorporate in the building of healthy soils. The second essential function of soil is sustaining plant and animal life. This means deviating from flat land, where large areas of cropland sustain only one type of annual, like corn, and moving more towards complex perennial-based systems which promote biodiversity. The NRCS states, the diversity and productivity of living things depend on soil. Not only that, soil depends on the diversity of living things which live within it, because, as we said earlier, they create it. This is a mutually beneficial or symbiotic relationship. Soil health means biodiversity. The third essential function of soil is filtering and buffering the potential pollutants. The NRCS states the minerals and microbes in soil are responsible for filtering, buffering, degrading, immobilizing, and detoxifying organic and inorganic materials, including industrial and municipal byproducts and atmospheric deposits. Additionally, mycelium, the white web-like filament in soil, which is the body of which mushrooms are the reproductive organ, is a phenomenal example of how healthy soil filters and buffers potential pollutants. It has trillions of nodes which traverse the soil, digesting complex molecules of not only plants, but also toxins like hydrocarbons from your car tires. Mycelium is extremely adaptable. The moment it creates a genetic expression which is successful in breaking down a new toxin, it will reproduce that enzyme and go into that toxin, dismantling it. At the same time, Adidas has created a mycelium leather sneaker, the Stan Smith Milo, and mycelium has shown tremendous potential in its application. From replacing plastic grow tubes for trees, to being combined with hemp and cotton to make a fully regenerative building material which continually stores carbon and moisture when grown, as opposed to the continual release of carbon caused by clear cutting of trees. It's as sturdy as wood and less susceptible to rot. The potential applications of mycelium beg the question, could we reverse the effects of hydrocarbons in soils and waterways by creating tires out of mycelium? Healthy soil filters potential pollutants and also buffers them. Buffering against toxins makes me think again of the permaculture water management pioneer Ken Yeoman. Remember, I said they're interrelated functions. Yeoman advocates the use of strip forests along waterways to minimize runoff of sediment and toxins into the waterways. Again, buffering. Maybe this is why it's called a riparian buffer. The fourth essential function of soil, according to NRCS, is the cycling of nutrients. Carbon, nitrogen, phosphorus, and many other nutrients are stored, transformed, and cycled in the soil. Healthy soil does all of this on its own. So once again, external inputs like synthetic fertilizers are not needed and actually disrupt the little critters, which do this just fine on their own. Roots of mycelium store a significant amount of carbon, while repetitive tilling of industrial agriculture releases carbon continually. This part is quite simple. A 2007 study on the Boreal Islands in Sweden found that roots and their related networks like mycelium store up to 70% of the island's carbon. Beyond just storing carbon, a talking point the corporate green movement has seemed obsessed with overlooking the agricultural implications of, healthy soil cycles all the necessary nutrients to grow food and human consumption. Chris Trump, an organic macadamia nut farmer out of Hawaii, forging the way by scaling liquid indigenous microorganisms, states that his farm has ample nitrogen in the soil without any need for inputs, besides the IMOs, of course. Healthy soil cycles nutrients. The fifth essential function, according to NRCS, is providing physical stability and support. Soil structure provides a medium for plant roots. Soils also provide support for human structures and protection for archaeological treasures. This is pretty self-explanatory. So, what does the NRCS say about how to manage healthy soils? They actually have pretty solid principles. The main principles for managing soil for soil health are maximize living roots. Soil and roots go together, and roots also lead to increased stability of soils. Minimize disturbances, meaning minimal overturning of soil or minimal tilling. Maximize biodiversity, meaning moving towards complex systems, or differently put, moving towards the way of nature and away from flatland. Maximizing living roots and increasing biodiversity means integration of various plant species. It means the integration of woody perennials or trees and shrubs. It means the integration of livestock and wildlife, whether it be chickens for composting and eggs, or 5 types of livestock, an owl and a band of coyotes. all of which can serve a function in a well-balanced regenerative or permaculture system. Biodiversity breeds resilience as each additional plant or animal serves a function in the ecosystem. The future of agriculture is finding the optimal balance between complexity and/or biodiversity and efficiency through simplicity in order to optimize yields of organic foods as well as foster healthy soils and ecosystem, all of which are related. Those in regenerative agriculture have demonstrated the advantages of integration for not only soil health, but the overall health of the system, including their profits. Principle 4, according to NRCS, is to maximize soil coverage. There are many methods to minimize soil disturbance and maximize soil coverage, like using a clover ground cover, which helps it retain moisture and protects it from sun exposure. Clover also feeds the soil nitrogen. It's medicinal and apparently edible. Another method of minimizing disturbance and maximizing coverage, called the no-till method, has proven quite successful at scale. Lancaster County, Pennsylvania, with its Amish energy, is a beacon for agricultural innovation with 70% cover crop and 70% no-till. Steve Groff was the first to develop a cover crop roller in the US, thousands of which have now been produced in Pennsylvania. As a young man, he was originally looking for solutions to ditches caused by erosion. They literally had to fill them in each year just to harvest. Talk about inputs. The search for alternatives brought Steve to begin no-till farming practices, forging the way for scaling no-till agriculture in the US. Here's a clip of them doing CBD hemp transplants as both a cover crop and a cash crop for the Hershey Medical Center's cancer research. Pretty cool, huh? So, we want to maximize roots in the soil as well as biodiversity. We also want to minimize disturbances to the soil and maximize the covering of it. I'd like to give a shout out to the Natural Resource Conservation Service for the integrity of their assessment on soil health. As they state, as world population and food production demands rise, keeping our soil healthy and productive is of paramount importance. By farming using soil health principles and systems that include no-till, cover cropping, and diverse rotations more and more, farmers are increasing their soil's organic matter and improving microbial activity. As a result, farmers are sequestering more carbon, increasing water filtration, improving wildlife and pollinator habitat, all while harvesting better profits and often better yields. Permaculture, a permanent agriculture, combining the best of indigenous practices, modern science, and technological innovation, is the way of the future. And the future is now.